maximum or minimum values of a quadratic function. Let's take a look at how to determine the maximum or minimum value of a quadratic function. Quadratic functions are used in a variety of ways. Engineers might use them to determine the maximum height or minimum clearance under the support of a bridge at a variety of points if they are civil engineers and they are designing bridges. Architects use quadratic functions to enhance building designs. So let's take a closer look. A quadratic function can be written in three forms, but let's start by reviewing the key components of a quadratic function. First, we have the y-intercept. This is the point where the graph crosses the y-axis. You can also have, but not always, two x-intercepts. This is the point where the graph crosses the x-axis. The vertex is the point at the bottom or the top, depending on how the graph opens, that represents the maximum value of the graph or the minimum value of the graph. The axis of symmetry is the line that passes through this middle point. Now, let's look at the three forms. First, we have the standard form, written f at x equals ax squared plus bx plus c, where c represents the value for, you guessed it, the y-intercept. The c represents the y-intercept value. Factored form, f at x equals a times bracket x minus r bracket x minus s, where r and s represent the x-intercepts. And the third form is the vertex form, where y equals a to the x minus h squared plus k. H and k represent the coordinates of the vertex. Now, we're going to learn in this video how to convert a quadratic function from the standard form to the vertex form using a technique called completing the square. And we're going to do that by looking at some sample questions. Here is the first one. Sample number 1. Write the equation y equals x squared plus 6x plus 7 in vertex form. Solution. Split the equation into two parts. X squared plus 6 go together, leave some space, and put plus 7. Take the middle term and divide by 2. So 6 divided by 2 will give us the 3. Now, take the result from step 2 and square it. So we will take 3 squared and we will get 9. Number 4. Add and subtract this value in the equation between the two parts. Remember, you can never change the value of an equation. So if you do it to the right, you do it to the left. If you add, you also have to subtract. And that is why we need to add plus 9, the answer from step 3, and subtract 9. So we're not changing the value of the equation. Once we've done that, we're going to group the first 3 terms as shown in blue, and we're going to group the last 2 terms as shown in green. Then we're going to simplify the perfect square trinomial. So x squared plus 6x plus 9 is x plus 3 squared. And now we're going to simplify the last part of the expression to get negative 2. So the vertex will be negative 3, negative 2. Always remember to take out the the h value 3, but change the sign. So if it's a positive, the vertex will be negative. If it's negative, the vertex will be positive. Now, let's take a look at a second example. Write the equation y equals 2x squared minus 4x plus 5 in vertex form. So the solution: factor the a from the first two terms only. In this question, the value of a is 2, so we're going to factor out 2 from the first two terms. 2x squared divided by 2 leaves us x squared. Negative 4x divided by 2 gives us negative 2x. Notice that I've now placed these inside square brackets. There's a reason for this. You will find out soon enough. Now, take the number in front of the x term inside the bracket and divide by 2. So negative 2x divided by 2 will be negative 1. Take the result from step 2, negative 1, and square it, and we will get 1. Add and subtract this value inside the equation as shown by the brackets. So we will get 2 bracket x squared minus 2x plus 1 minus 1 bracket plus 5. Remove the term with the negative value from inside the brackets by multiplying it by the value in front of the bracket. So we want to take out the negative 1 from inside the bracket, so we multiply it by 2, which is the number in front. So we are going to get y equals 2 bracket x squared minus 2x plus 1 bracket plus 2 minus 1 plus 5. Simplify the perfect square trinomial inside the bracket. We will get 2 times bracket. Now we're going to use round brackets to show the term. X minus 1 squared plus 2 times negative 1 plus 5. Simplify the last part of the expression. Y equals bracket bracket x minus 1 squared bracket minus 2 plus 5 will become y equals 2 x minus 1 squared plus 3. So our vertex will be 1, 3. Sample number 3. Write the equation y equals 1/2 x squared plus 4x in vertex form. Solution: factor the a from the first two terms only. Y equals 1/2 x squared plus 8x. But where does the 8x come from? 4 divided by 1/2, which is the a value, is equal to, remember to divide, you multiply and flip it, so it's going to equal to 4 times 2, which would be 8. Step number 2. Take the number in front of the x term inside the brackets and divide by 2. 8 divided by 2 is 4. Now, take the result from step 2 and square this result. 4 squared is equal to 16. Add and subtract this value in the equation inside the brackets after the x term. Y equals 1/2 square bracket x squared plus 8x plus 16 minus 16. Now, remove the negative value from inside the brackets by multiplying it by the value in front of the bracket. So we're going to remove negative 16, remembering to multiply it by 1/2. So we will get 1/2 bracket x squared plus 8x plus 16 bracket minus 1/2 times 16. Now we're going to simplify the perfect square trinomial inside the bracket. 1/2 x plus 4 squared minus 1/2 16. What's our next step? Simplify the last part of the expression. Y equals 1/2 x plus 4 squared minus 8. State the vertex. The vertex is -4, -8. The next video in this series is on using maximum and minimum values to solve quadratic functions.